strange issue. No more control on my PC. So let's start again. Okay, F5. Thanks to our sponsor. Without them, it's not possible to have such a conference. And a big thanks to the strategic partner, Microsoft, and the gold sponsor, and even a silver sponsor. Everything is good to make some events to be online. So I was telling this session was about the evolution of SQL Server from Docker to big data cluster, and we will start with a bit of archaeology. First, a few words of myself, and you can hear my sexy French accent. I live in Toulouse, in the south of France. I'm working on SQL Server since 1997 on SQL 6.5 on Windows NT 4. And since that, I'm certified on SQL and Windows and Azure. I'm actually a SQL Server master and also an MVP since more than 12 years now. You can reach me on different social media, as you can see it. Once upon a time in 1989, SQL Server was born. And at this time, SQL Server was running onto OS2. And that was a fork from Sybase. It was a joint project between Microsoft and Sybase and other Ashton Tate, another company, to just port Sybase on another environment. And after that, in 1993, SQL Server was landing on Windows NT. It was on version 4.21a. That was the first time SQL Server landed on a Windows environment. And in 1995, SQL Server 6.0 marked the end of the collaboration with Sybase. Two different products since the SQL Server 6.0. Starting with 6.5, that was the beginning of my journey using Server. That's an interesting version because that was the first time there was some clustering feature, and SQL Server was respecting more the ANSI syntax of T-SQL. And that's the first time we see a very, very useful tool called SQL Trace, that's just the ancestor of the SQL Server profiler. SQL Server 7.0, very interesting version because it marks the end of source coding inside SQL Server, and since this moment, everything is written in C++ or in .NET in the future release of SQL Server. As you can see, there is something quite strange and funny using SQL Server 6.5. It's that we've got some mirroring option inside SQL Server. Not mirroring as we know that nowadays, but it was just a mirroring to duplicate the file on the same drive or different drive on the physical layer. Just because at this time, the database was made by only one file. And if we want to have some redundancy, like a RAID system, we just have to duplicate and to mirror the file inside SQL Server. That was funny at the time. SQL Server is always evolving because Microsoft is adding new functionality like temporal table, graph databases, HADR capabilities like mirroring or like availability groups. And also there are a lot of security improvements like the TD, like always encrypted, row-level security, and dynamic data masking. Everything is very, very important regarding the RGPD, law enforcement, and so on. SQL Server is also evolving regarding the extensibility, because we can write some T-SQL code, but we can also have some storage procedure and function that rely on C# or maybe VB.NET if you prefer that, because SQL Server is able to handle the SQL CLR, the Common Language Runtime. And in the more recent version of SQL Server, we are able to write some code using Java or Python or R for the BI stuff. Also, you are able to use Polybase. Polybase is a kind of super linked server very, very powerful linked server to access data inside Cosmos DB, Teradata, and other systems like that. Also, there are a lot of performance enhancement, like in-memory OLD, Hackathon, or the column store indexes. You have also the new cardinality estimator and the new feature inside the TimeDB, like the TimeDB scalability, which rely on Hackathon. Also, you've got the intelligent query processing that allows you to remove the pitfall of earlier version of SQL Server, like the use of scalar function. Sorry. SQL Server is evolving, but every application in the world was also evolving. When I start doing some computer development, it was on COBOL and it was on mainframe. And the application was mainly monolithic, very, very difficult to make the application evolve and to maintain this application. When you were submitting a batch to compile the application, it just takes a while, and on the next day you've got a large stack of folder of a file with every error you have on your program. It was awful. Today, we are talking about microservices. Microservices, it's a new pattern, a new way to develop application. The application can be made of 1 or 10 or 1,000 containers, and each of these containers is very, very lightweight, and each container is able to evolve independently from the other. So the application is more maintainable. It's more easier to make the application evolve. It seems to become a standard from an infrastructure perspective, but also from a DevOps philosophy. Today, when some people want to launch a new application, they are thinking first to use containers. For DBA, what does it mean? Before thinking of containers, we have to speak about virtualization. 15 years ago, we were wondering, should I virtualize SQL Server on which hypervisor? Is it VMware, or is it Hyper-V, or is it maybe another one? By the way, the first step of virtualization was hardware virtualization. It means that we could build some virtual machine on top on an hypervisor and on top of a kind of hardware, and can run a lot of virtual machine on top of this hardware. Very, very useful. And SQL Server has entered the virtualization world. I think from a serious perspective, it was in 2008 or maybe 2010. The second step of virtualization is named containerization. The main difference is that we no longer have some guest OS to maintain. That's very interesting because the infrastructure layer, the hardware, is more utilized. Containers are very, very interesting because can deploy, and we will see that in a few minutes, we can deploy application very, very fast. And those applications are isolated from the network. That's a key point. No container is visible from the network. And if you want to connect to an application inside the container, you have to plug a kind of netting or routing inside the container runtime. That's the job of the container runtime, and you don't have to worry about that in a technical manner. And the other key point for a container is that it is stateless. It means that if you stop the container and if you remove the container, you no longer have access to the data inside the container. So the container is very, very interesting for pieces of code, web services, application, and so on. But for database, that's a little bit different. For DBAs, What are the advantages of a container, of running application inside a container? The first thing is the footprint. It is a very, very small footprint. Each container is very, very light. So we have a better efficiency on the servers. And also, you've got a single image. How many times in my life I heard someone, a developer, saying, okay, but it works on my computer. That's not fair that it's not working on the production side. You cannot have this behavior when you are using container, because you can use the same image to make multiple deployment of your application. One on the test environment, one on the prod environment, and it always works the same. That's very, very interesting, regardless where it is deployed, on your machine or on your production grade server. The deployment is very, very fast, as we can see in a few seconds. Deploying a container means that we are looking to the registry. A registry, just a store where there are a lot of images ready to go, ready to use. Maybe it's a web server, one Apache or IIS, maybe. Maybe it is some kind of database. By the way, you've got a lot of images ready to go. And after you pull one of these images, you download the images on your computer, and then you start a container using this image. And everything runs fast using this kind of deployment. It's very, very fast to deploy an application. The most known of container engine is Docker. Docker has democratized the container, the container way of running application. There is two sides inside Docker. The first one is the Docker engine with this, which is responsible for running the container. And the second one, it's a command line. So it is Docker client. And we can interact with the Docker engine using the CLI. There are some alternatives to Docker, maybe Podman, Mesos, or LXC, or RKT, by the way. But there are not only one Docker, not only one container engine to run your containers. One interesting thing with container that there can be run everywhere, on Windows, on Linux, on Mac, with the same command line. And you've got exactly the same behavior from your application. If you want to try that, that's very easy. You can use Docker for desktop if you are a Windows guy, and if you are maybe a Linux guy, you can use every flavor of Linux and download the Docker engine to have a try. It's very, very interesting and very, very easy to use. You can try that if you want. What are the different command lines we can use with Docker? We can search and pull an image. We can create a container. We can start a container. We can run a container. That's a magic command. Docker run is a magic command that will automatically pull an image. If the image is not on your computer, and after it just run the image as a container. You can stop and you can remove the container if you want. You remove the container, Docker RM, there is no more data you can access after that, because everything is dropped. Container is stateless. Can have some hello world demo, for example. Let me grab the correct file. It is this one. I will connect to Bash, that's better. I will connect to a host that will contain my Docker engine. And I will connect the same on the other side. Okay, I'm connected to an, oops. Good. I'm connected to an Ubuntu server with nothing fancy on that. Clear. And I can have some command line information if I just run the Docker command, and you see all the options you've got if you run the Docker. You've got exactly the same if you are using Docker on Windows. You can see the version of Docker if you want. You've got a lot of images. Maybe none of them are already pulled, but we can download some of them. We can also have some Docker container list. What are the containers actually running on this machine? I just am adding the watch, and you see that I have no container running on my machine right now. But if I just use the Docker run hello world, it will just download the image and run the Docker container. Hello from Docker, everything is fine. I can run a container very, very fast. The image has been downloaded. We can see the pool complete. And after it just run the container, we can see it there. And that's a simple container. It is already exited. There is nothing running on that. I can use another container based on Ubuntu image. Sorry, F8. I see that the Ubuntu has been downloaded and run, and I am now inside my container, so I can run a bunch of commands because I am inside my guest OS. That's not really a guest OS, but I am inside my container, and I can do a lot of things inside my container. I can install maybe an application and then save the container and then upload the image to a registry to be able to use it in production, for example. And you can see that I have my container running there. I can exit my container. And maybe if I just want to make some cleanup, just have to stop and to remove my container. And you can see that I have no more container running on my system. That's very, very easy to use. Right. There are any questions right now? Maybe having a lot looked. Seems to be okay. So, container can run all kinds of applications, and I'm sure that we are able to run SQL Server in a container. But we need some extra stuff because a container is isolated from the network. So if you want to access your database inside the container, you have to make some TCP port redirection. You have to make some netting. And also, if you want to keep your data alive after you remove your container, you have to use some kind of persistent storage, just to be sure that if you shut down the container, remove the container, and spin up again this container, you will find your database as it was before the operation. Microsoft has published some images since 2016 with SQL Server 2016, and as you can see, that's a screen capture on an old SQL Server Saturday talk I gave in Montreal. It was in 2017, and as you can see, I was using SQL Server 2016 inside a container, but it was a Windows container. It was not on Docker at this time. And that was some official images from Microsoft. Next, SQL Server 2017. A very, very interesting announcement made by Scott Guthrie. SQL Server will be now available on Linux, natively on Linux. That's a big deal, and we will see that in a few seconds. Installing SQL Server on Linux is very straightforward. That's an old screen capture, as you can see, because it is Ubuntu 16, and right now you can use SQL Server 2019 on Ubuntu 20, the long-term release of Ubuntu. And the flavor supported for installing a SQL Server on Linux is Ubuntu, Red Hat, or SUSE. But you can try to use other flavor of Linux, but you may not have some support. It works on CentOS, it works on Fedora, and so on, but you don't have support on these flavors. Installing SQL Server on Linux is very simple. You just have to locate the package from Microsoft and just have to use the apt-get install -y MS SQL Server, and it will download maybe 300 megabytes of SQL Server binaries on your computer. Once done, you just have to launch the setup command to configure SQL Server. And this command of MS SQL conf will just ask you for an edition of SQL Server. Which one do you want to use? And after, are you sure that you want to accept the license agreements? You give the SA password, and that's done. You're done. SQL Server is up and running on your Linux box. So the installation is very, very straightforward. You can make more configuration steps, like moving the file on different volumes and so on. But to install SQL Server, it's very, very simple. Question is, how Microsoft port SQL Server on Linux? That's a great question, because when they thought to moving SQL Server on Linux, they just estimated that it was necessary to spend 5 years to make a native porting to Linux. That was not possible to use this kind of and to spend a lot of time to move SQL on Linux. So they tried to decide. They decided to try to think different. If you are looking to a deep level of SQL Server, which is called SQL OS. SQL OS is a layer that is responsible for scheduling, for managing the memory, for managing the threads, managing the I/O, and so on your SQL Server. And the SQL OS was the only one that was sending a request to the hardware and to the OS, the OS Windows. And Microsoft decided to make a prototype, which is called SQL PAL, Platform Abstraction Layer. Microsoft decided to make a prototype in 3 weeks to just reroute the call for the API for Windows or Linux to make some I/O, to grab some memory, or to schedule some tasks on the computer. And using the SQL PAL, Microsoft has found a good solution to port SQL Server on Linux, because it is exactly the same .exe file that runs on Windows and Linux. And 3 weeks to make a prototype and 2 years to release the final release was very, very quick. The interesting part is that if you are developing something inside SQL Server now, it will be available on all flavor of SQL Server, because everything goes through the SQL PAL. Why Microsoft decided to port SQL Server on Linux? Just because everyone was expecting that. ISV and customers, and also we have to be fair, just to win some market share, because a lot of people want to change maybe from Oracle to SQL Server, but they want to keep the OS on Linux and not on Windows. SQL Server is now everywhere, and SQL Server 2017 was the first version available on Linux and officially supported by Microsoft. That's a big deal, because Microsoft has to provide the support tools and the support team to help you in case of issue if you are running SQL Server in Linux. That's why there are not all flavor of Linux that are supported right now. You can create with the exact same command line a container running SQL Server on Docker on Windows, Docker on Linux, as you can see on my screen right now. That's very interesting because the end user experience is exactly the same when you are using SQL on Linux, SQL on Windows, when this SQL is inside a container. I have a small demonstration about that. I'll have to reconnect to my Ubuntu server. And you can have a look to all the images provided by Microsoft, official images provided by Microsoft for SQL Server. You can see that there is SQL Server 2019, 2017, and that's all for the moment. And as you can see, for SQL Server 2019, you've got a support for Ubuntu 2004. That's the first time SQL Server is supported on this version of Linux. You can grab any of this version of SQL Server right now. And I have already downloaded a few of them. As you can see, I have downloaded the CU8 and CU10 of SQL Server, but for me it is on Ubuntu 2004 for some reason that I will not explain here. I can grab another one, the latest version, if I want. If I just want to run SQL Server inside the container, I have to call the Docker run command and give some information. What the host name of my computer inside the container was, what is the name of my container from outside, and after which edition of SQL Server, my super secret SA password, and after I've got a bunch of redirection, volume redirection, to be sure that I can store the data of my database on the host and it will resist a remove of my container. And after, I will also publish a TCP port to be able to access my SQL Server. And then I just have the name of the image I want to use. And that's done. My SQL Server is now up and running. I can have some information, some log, and if you are familiar with SQL Server, you can notice that it's an error log from SQL Server. I can connect using the SQL CMD, and I have the information that's a developer edition running on Ubuntu. That's good. I have some database, master, TimeDB, model, and so on. I can go, if I want, inside my container and having a look to everything, because that's a kind of OS I can enter if I want. I'm going inside my container. I can create a database, just have a look. My database is here, and I can have a look to all the data file, nothing fancy here. Okay, exiting the container. I'm back on my host right now. And what I'm going to do, I'm going to stop and to remove my container. Done, but as I made some volume persistence, I still have all the file on my host computer. And if I choose to this time running the CU10 of SQL Server, it will just take a few seconds, maybe a minute, because SQL Server will upgrade the databases to the new version of SQL Server. If I'm looking at the log, you can see that everything is upgrading right now, and it will take a few seconds to perform. Once done, I can check that all my databases will be there. Everything was fine. I can make some upgrade version of cumulative update. But if you are using cumulative update, downgrade is also possible. You can set up the QU 10 and then revert to CU 9, for example. That's not that's possible with Docker. Okay, that's not recovery complete. That's done. So I can check that everything is fine. Oh, sorry, I don't do what I want. I've got my database, and now I am on CU 10. Where is my CU? Here, it is my CU 10 of SQL Server. So that's very easy. Spinning up some container is much faster than running VMs because it is lightweight. And I'm running here a bunch of containers. All of them are running right now and are able to perform some T-SQL workload, to handle some T-SQL workload. I'm not able right now to spin 5 virtual machines running SQL Server as fast as I can spin 5 containers with SQL Server. That's the main benefit of containerization. I can access from outside, of course, because everything is set up correctly. I just remove everything for this one. Okay, SQL Server inside the container works perfectly. But the bonus is that if you are using maybe a Raspberry Pi 4, you can run SQL Server. That's a specific edition of SQL Server, which is called Azure SQL Edge. And SQL is running inside the container on my Raspberry. This specific edition is made for time series, data processing, data streaming, in database, machine learning, and graph features. That's very interesting. You are putting your SQL Server on the edge of your network to grab information from some hardware acquisition card on your fabrication lane and so on. That's very, very interesting. That's a kind of InfluxDB database, very interesting. And you can synchronize this database, this SQL Server with Azure, for example. So you can run SQL Server on a Raspberry Pi machine. Very, very interesting. And if you want, after the show, I can show some demonstration about that because I have one installed right now. Oops, sorry. Now, what's next? Oh, a bug in my slide. We need some orchestration for containers, just to be sure that my container is healthy. And if it's not, I want to restart my container and ensure that the host is healthy. If my machine is down, I just want to restart the container on a different host. And I just want to provide a network access to my container wherever the container is running. And also to provide some persistent storage across multiple nodes. That's just a cluster. It looks familiar because all this kind of question rely on a cluster. And the cluster may add some interesting feature also. Maybe adding live some resources or managing the resources like the CPU, like the memory. And also maybe adding some scale out, some scaling feature to add more containers if you are under an heavy workload, for example. That's an interesting feature because if you have a website and suddenly a lot of people is connecting to your website, you can add multiple containers running the same website to handle the workload. But for SQL Server, that's not possible. SQL Server is not stateless. SQL Server is stateful, so you cannot make some scaling out using container and SQL Server. And if possible, we wish a similar deployment experience on-prem or on the cloud. That's why we've got some orchestrators like Kubernetes, like Swarm, or on-prem like OpenShift, and Rancher is also a good one. That's the main known. Of course, there are other orchestrators available on the market. So Kubernetes, that's just a cluster made of master node that will interact with the worker node to ask them to spin up a container, to spin up a pod, and make it available as an application. So the master node is responsible for scheduling, and the worker node are responsible for running the containers. We are not talking about containers. We are talking about pods. Pod is just the smallest management unit available in Kubernetes. It's made of one or more containers, and each pod has an unique IP across the cluster. If the pod is moving from one worker node to another, it will keep its IP address. The interesting part is that the kube proxy will make some network management to be able to reach the container, the pod, wherever it is running. So the kube proxy is just a traffic management, a network traffic management manager that will redirect all queries to the right pod inside my cluster. Kubernetes is maintaining what is called a desired state configuration. It means that if you want to have one copy of your pod running, Kubernetes is responsible to make only one pod running, but at least one pod running. If you want two of them, Kubernetes is responsible to make two of them running at the same time. And if everything goes wrong for one pod, Kubernetes is responsible to spin up a new one and to continue to handle the workload. How can we connect the applications? All application goes through the kubectl, as we saw. And no matter the worker node, we will be able, with natting and routing, to connect the correct pod. Inside Kubernetes, there is something like a call called services. Services exposes application, and an application is just a logical abstraction of one or more pods. There are different types of services. The first one is a cluster IP. The cluster IP means that I can connect to my pods using load balancing if there are more than one, but I can connect only from my Kubernetes cluster. Only the internal traffic will be able to connect to the pod. So my application is not available from outside. If I want to be able from outside, I can use the node port. I can connect to each node of my cluster on a dedicated TCP port, and the node port and the kube proxy will load balance and connect my application to the pod or the pods that are handling my application. And the next one is the load balancer. The load balancer takes traffic from outside and will load balance on all nodes of my cluster. And the difference between node port and the load balancer is that I don't have to have a specific port on each AKS node, for example, the 31,000, like for a traditional IP port, like port 80 or 1433 for SQL Server, and so on. The main difference is there. when you are using Kubernetes on public cloud, there is always a load balancer included in the solution. Some command like the Docker one, you can create some pod, you can make some apply. Why we are calling that? Because you are giving some YAML file that describe your application with the storage, with the container, with the service, and so on. And if you are looking to a YAML file, whatever it contains, you have different sections, and the section describe your application. And when you apply a file, as there is a desired state configuration, Kubernetes will create the missing services or the missing part, or remove some of them if it is not necessary to have them. So if you want to deploy something, you will just have to use the kubectl apply something. And if you want to remove, kubectl delete something. SQL Server inside Kubernetes, it works and it is suitable for production. Yes, that's the next level of the virtualization. HA is enabled by default. Just think about a failover cluster instance. You've got some persistent volume on the cluster, and remember that Kubernetes is responsible to maintain the desired state configuration. So, in case of a failure, Kubernetes will try to spin up the pod on the same node or maybe on another node. It depends of the error. But that's very interesting because you've got SQL Server up and running inside the cluster, and that's very interesting. I prefer this solution that a standalone server inside a virtual machine, because the virtual machine doesn't guarantee that your SQL Server is running inside Kubernetes. It is guaranteed that you can access SQL Server. The application will reconnect using the same IP address, the same port, and Kubernetes will just redirect the network traffic to the new pod created. A bit of history. 10 years ago, we were wondering if it was a good idea to virtualize SQL Server. And at the same time, Microsoft was releasing some cloud services called Azure, Windows Azure Platform. SQL Server was one of the first services provided on Azure. Nowadays, you've got SQL Machine, Managed Instance, Azure SQL databases. That's not the purpose of this session. But you've got also some containers as a service feature like ACI or AKS. ACI, very, very easy to spin up a new container, but that's not very suitable for production because you don't have that's not very, very useful for production because you are built for the second. If your workload lasts a lot, that's not that's not a good idea. But if you want to include some SQL Server instances inside a CI/CD pipeline, for example, ACI is a good idea for that. AKS, deploying SQL Server inside AKS seems to become a standard right now. Very easy to deploy. You just have to provide a YAML file describing your SQL Server, as you can see on my screen. I have a few minutes left, so I have to go ahead. Okay, good. Right now, I've got a few nodes. Exit. I've got a few nodes on my cluster. Come on, a 3-node cluster created 2 days ago. And actually, I've got some pods. All the pods are containing one or more containers. I've got some namespaces also. And you see that I've got some MS SQL cluster. We will see that in a few seconds. I can create my own namespace. Okay. And here I'm just looking at all resources created. I'm oops, this way. I'm creating a secret, and I'm going to apply some load balancer, some storage, and some deployment. Deployment is where SQL Server is exposed. And I'm going to apply all this YAML file. All the source code will be available on my GitHub and so on. And I'll just have to wait for a few seconds that my external IP will be available to connect to SQL Server, and also to be sure that my deployment is okay. Since I'm not one-on-one, that means that my container is still creating, it's running, I'm now one-on-one. That's my IP address, my public IP address. I can grab it and I can connect on my SQL Server right now using SQL CMD. I'm running SQL Server inside the Kubernetes. I can, if I want, create a database, and my database is there. Yes, it is very critical. So what happens if I'm deleting my pod? I am deleting my pod. You will see there that another one will be spin up. You can see there. And the other one is terminated. Once done, I can see my database. They are still there. So that's very interesting. My desired state configuration make my SQL Server highly available. Come on, I have not enough time. It's not there yet. And it will come. So I'm sorry, I'm short time. AlwaysOn Availability Group. I'm sorry, that's not available yet inside the Kubernetes. You can use, if I can remember, you can use some read scale out capabilities, but not AlwaysOn Availability Group for HA inside the Kubernetes. You can run SQL Server inside Kubernetes, and Kubernetes can run any kind of application. SQL Server is more than a database, because we can access some external table through Polybase. And we know that the pod can host multiple containers. So we can add some big data containers with Spark and HDFS. That's a big data cluster. When we are talking about big data cluster, we are talking about SQL Server, many instances of SQL Server running inside Kubernetes. You've got some master instance, the only instance you connect, and after you've got some compute pool to provide some Polybase scale-out capabilities. You've got some storage pool with SQL Server, and the magic happens because inside these pods you've got Spark and SQL Server and HDFS node. And after you've got some data pools, because the master instance will create automatically some external table relying on those databases inside the data pool. 2 minutes, it will be good. Let's change to this guy. Connect my big data cluster. I created 2 days ago. It's good. So I can connect. Come on. I can connect. Come on. I just want to click. Thank you. I can connect to my big data cluster. That's a SQL Server, a traditional SQL Server. I'm hitting the master node. And on my master node, I can see, okay, that I am on SQL Server 2019, CU10, blah, 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 blah. I can create a demo database. And on this database, I can create an external data pointing to my HDFS cluster. And I put some data on this HDFS cluster. It is some CSV files and so on. I can create an external file format, and an external table using the file format. And after, if I want, I just have to perform some queries. I'm short of time, so this notebook will be available. If you want to try it, there is no problem with that. The interesting thing with big data cluster is that we can query one file, or maybe we can query a folder with multiple files. That's the case here. If you want to query a folder with 100 of files, that's okay for that. But the magic happens. Come on, scroll. You can switch to another engine, to Spark, for example, and the BI guy will be happy with that. You can switch to PySpark and perform some queries using this kernel. I think I have an issue with my big data cluster, by the way. You can show the information from all the files. You can filter the information if you want, or add many filters. Okay. And also, you can use some T-SQL-like syntax. You can use the select statement, and you want the temperature and the humidity of my sensors. Or maybe you want a summary of the information. Or you can write some real T-SQL statements. You can create a view and then use some real SQL statement to perform queries on Spark, on my HDFS cluster. And you can have the overclose if you are a big fan of the overclose and so on. Very, very interesting to use the big data cluster. SQL Server is really entering a new era because SQL Server is constantly evolving, new features, new capabilities. We saw that. SQL Server on Linux was a milestone. That was an achievement, was not an achievement. Having SQL Server landing on Linux was very interesting for the future. And SQL Server is everywhere now, on Windows, Linux, Docker, on Kubernetes, on-prem, on cloud, on the edge, and maybe on your Raspberry if you want it to be on your Raspberry Pi. And you've got also a new architecture. It means that maybe the new version, but the future of SQL Server will use more scale out than today. Because if you are looking to a SQL Server hyperscale on Azure, the architecture is breaking the monolithic SQL engine because you've got some compute node, page server, and you've got some remote storage. And this kind of architecture is very, very interesting. That's really a new era for SQL Server. Thanks for attending this session. I'm sorry for the small technical bug at the beginning of the session. Feel free to reach me on the different social media, and if you've got some question, feel free to ask right now.